Hi, this is Ryan from Ready Rhino 1, and I want to do a quick podcast. Well, maybe not a quick podcast. I mean, quickly start it, but maybe it'll go a little bit longer than what you would think be a quick podcast. I haven't done a podcast in some time. Just been dealing with a lot of, work got really kind of crazy, and the holidays are starting up, and my family does things a little bit differently, in that we kind of celebrate things a little earlier than that, than the actual day. But I want to talk a little bit about something a project that I had done a couple of years ago. This was a file server. So originally I had, I think one of my old desktops, I had just kind of loaded with a bunch of disks, right? And then shared them just with Samba or something. And it was nothing really special, but it was something to just, like we can put stuff on them and that way they're somewhere else, not necessarily on our local machines. I started to get into thinking, like, I'm running this thing all the time and it's not really giving me a lot, right? And there's no scalability with it per se. I mean, all I can really do is just add some more disks. And there's really not a lot of fault tolerance with it either. And, if the house were to burn down, we kind of lose a lot of stuff. And then we were also up against the fact that we were just running out of space, right? So I had bought a couple of external hard drives that we were just kind of putting family pictures on. This, again, was not really a safe thing. So I had this, like, process set up where you would empty the phone of family pictures that we'd taken over the course of a couple weeks or whatever, and then you would put them onto your local machine, and then you'd copy them over onto the external hard drives, and then you would take that, you'd start trying to burn them onto DVDs, and we were going to hold on to DVDs. This still didn't solve the problem of having an offsite backup. So there's the 3-2-1 of backups that you're supposed to follow. So you want backups in 3 different places across 2 different mediums and 1 offsite, right? 3-2-1. And I wasn't accomplishing that, and so that was kind of a little bit embarrassing, being someone who has a computer system background, that kind of thing, and my job kind of deals with that a lot. I wasn't really doing that personally, which kind of goes back to the old adage: the mechanic's car is the worst one, right? But so I decided, like, I really need to bite the bullet on this one because we were amassing a decent amount of family pictures, and it simply was not going to scale. And I had come across a couple of horror stories, of people who had all their family pictures on like on an external hard drive, and they lost the hard drive. It just died, because I mean, really, a lot of these external hard drives are just a single drive. Sometimes you can actually buy some where they'll have 2 drives inside the external closure, and there's like a really simple RAID configuration, which is a redundant array of independent disks, I think. I feel like I should know this, but I'm not really a storage guy too much. So, anyways, you would have 2 different drives that basically mirror each other, and so that if one drive dies, then you still have everything on the other one. So there is some fault tolerancy there. It's not the best, and I'm not really sure, like, if with those kind of external drives, I think it should, but maybe it doesn't. Like if you did have a drive failure, you should be able to pull that one out, the bad one out, and put a new one in, and then it will resilver the mirror configuration. Resilver, for those who don't know, it's an older term. Mirrors, actual mirrors that you would use to look at your own reflection, used to be backed by silver, right? So they would take glass and overlay it with a silver thing. And so over time, if you ever go to an antique shop, you'll see, if you ever find an old mirror, you'll see the backing starts to kind of come off. I don't think they use silver anymore for modern mirrors, but you could see the silver start to kind of peel away from the, and of course it doesn't become very reflective at that point. And so there was a method to what was called resilvering a mirror, to make it back into an effective 100% reflective surface. So they kind of borrow the same term when dealing with mirrored arrays of drives, right? So you just have 2 drives that mirror each other, and if one dies, the mirror is not really accomplishing what it was originally set out to do. And so there's a process called resilvering, or just, rebuilding your mirror. You just kind of put a new drive in, and it will copy everything from the existing drive that didn't die and over onto the new one. And so that way you're back into protection. So, little bit of rabbit trail. So anyways, I had decided that I needed to actually get a legitimate, file server set up, something that could hold a ton of images, something that could well, a ton of data, something that could, you know, had a lot of fault tolerancy and just kind of gave me some additional protections with things. And so I had played around with a free file server operating system. It's called Freenas, or Freenas, and NAS is network attached storage. So FreeNAS. Now I think it's they've kind of sunsetted FreeNAS, and now they're kind of moving to TrueNAS. And the people that make that IX Systems, I think they were actually running like TrueNAS, which is like an enterprise offering that they did sell. I'm not really sure how the licensing worked, it being open source software. I think they built it on top of FreeBSD, I think is what they did. And then they kind of modified it to specifically work as a NAS type server. But anyways, so IX Systems has like TrueNAS and FreeNAS, and they just decided to sunset FreeNAS and just kind of roll it up into like TrueNAS Core, and like then the TrueNAS is still their enterprise thing, and they kind of do different features for that. A lot of the features are things that I think most people aren't going to use unless you're a hobbyist. Mostly to do with high availability and failover of file servers and that kind of thing. That kind of gets into some craziness. To me, it's very interesting, but I don't want to get too far off topic. So I wanted to use FreeNAS. I had used it as for my file server that I had before, which was just a couple of disks and stuff, and it really wasn't that big of a deal. Anyways, I really wanted to make something that was very worthwhile, something that I could, you know, seriously use. And so I decided to kind of go that route. Now, I had previously purchased a actual server rack. I think it was StarTech, one of those actual like server racks. I have it out in my garage, and I had two Dell R710s racked into it that I've been kind of playing around with as just servers. Trying out different Linux distros and things like that, ESXi and whatever's free. So this was perfect. I was just going to basically put this, this file server in there. I was going to rack it in. And so so for this podcast, I wanted to kind of talk through a little bit of my configuration from the hardware standpoint and kind of what I did to kind of build all this. So in terms of hardware, what I decided to use, I found a 4U rack chassis, basically a server case from Rosewell. It was something I found on, it's probably not the best, but I mean, actually, for me, it worked out pretty well, right? So when I say 4U, I'm talking about the vertical size of these things. So on a server rack, you have like, every screw set in the rack, which is your vertical real estate, is 1U a piece. And so like the Dell R710s are 2U, so they take up two screw slots, right? So I've got 4 total. That's how big they are, and so all the servers kind of conform to this, so that you can easily add more servers. You can calculate, right? So if you have a total of like 32 or 36 U slots in your unit slots in your server rack, then I can break this up with like 4s, 2s, 1s, and that kind of thing. The 4Us are like probably one of the fattest ones. I'm sure there's probably bigger ones. I'm not really sure what they would be for. But so you can rack a bunch of different things. So you can rack smart UPS units in there. You can rack servers. You can rack networking equipment. A lot of networking equipment tends to be very thin, so they're about 1U a piece sometimes. Power supplies could be a little bit bigger and that kind of thing. So this is a 4U. It takes up 4 unit slots on the rack. But this is fine because I wanted enough room to be able to fit drives vertically into it, and that's just for ease of access. And so what I picked up was this thing has the case itself had several 5 1/4 slots. So if you ever built a machine, or you can even look on your current desktop machine, if you have one, or if you're working on a laptop, you won't have something like this. But I'm sure most of you have probably seen like a DVD drive that's in your desktop, whatever. So that takes up what's called a 5 1/4 bay. And this is a callback to when the older times when we had we'll have these cases. You had what are 5 1/4 inch floppy drives. These are those big black floppy discs that you would put in. I'm barely call it discs. I mean, you could actually bend these things, and you would slot them in, and pull down a handle to lock it in place, and that way it would read it from there. So these bays became standard 5 1/4 bays, and so a lot of things will fit in to 5 1/4 bays. Mostly when you're dealing with like DVD drives or some kind of disk drives. The hard drives tend to be about 2.5 inches in size, and some cases actually have smaller slots for that. But anyway, so I had found from ICDock, ICYDOCK, ICDock, they had these drive bays that were a little special, right? So they would expose like 8 different 2.5-inch slots for hard drives. And they would actually implemented a backplane in the drive bay itself. A backplane is something where you can like plug hard drives into very easily, and it kind of interfaces with whatever else is interfacing with the drives and kind of puts a little middleman in between and can actually maintain that there's a slot kind of open. And it's for hot swappable, right? So you don't have to shut the machine down in order to pull a drive. So you can just pull a drive while the machine is still active. This is what's called hot swap, and then you can push a new drive into that same slot, and the backplane kind of maintains that connection and ensures that the computer that's interfacing with it can still kind of it doesn't get all messed up or interrupted. So anyways, this takes up a 5 1/4 inch bay, and actually this one takes up 3 of them, I think, 2 or 3 of them, in order to provide 8 2.5-inch slots. I guess that makes sense, right? So 8 times 16 and some change, and then 15. Yeah, I think it's something like that. So yeah, I think it takes up all 3. So anyways, this case has 3 5 1/4 inch bays on one side and another 3 5 1/4 inch bays on the other side. And so I bought 2 of these things and slotted both of them in. And so these bays, of course, have connections for SATA cables, which is how a lot of hard drives now kind of interface with your computer. So you just kind of you plug in these drives, or you just attach them inside your case, and you plug in 2 SATA cables for power and for data. And so what this ICDock bay does is you kind of just plug in a couple of SATA power connections into it, and then several SATA data connections into the bay chassis or whatever itself, and then it handles any hard drive that's plugged into it, up to 8. So anyways, I bought 2 of these things, and when I got the chassis, just kind of installed both of them, took up all of the 5 1/4 inch bays. And so I had these things where I had about 16 openings that I could just shove drives into. And so the next thing is, this is a lot of drives, right? And there's not a whole lot of motherboards or main boards that are going to be able to have enough slots to actually get all this. A lot of times they'll have like 2 different RAID controllers or some kind of like disk controllers, and they offer like 4 each. So you got 8 total there, and then you got 2 more maybe that are just specifically for boot drives or something like that. And there's those additional 2, so you got like 10 total. Well, I'm looking at getting a bunch of drives in here. I was actually looking at getting 10 different drives, so I could have done this just through the main board, but I wanted to be able to scale, right? I wanted additional space to be able to slot different things in. So what I ended up having to do is, plus for performance reasons, I wanted to add what are called SAS cards. I don't want to get too technical with some of this stuff, because I think a lot of people who might be listening to this podcast really don't care, but some people might. So I chose 2 SAS cards. LSI is the brand, and they're 9211 8i 8-port 6 gigabyte SATA SAS PCIe 2.0 cards. Now these are a little bit different. Most people probably haven't seen these. People who build servers definitely have seen these and may have not even use them. They might be going for like a PERT controller or some other kind of RAID controller for some more higher end applications. But this one actually did pretty well. It was affordable, and it did exactly what I wanted it to do. So what these LSI SAS cards do is they expose SAS connections. Each card has 2 ports, And these SAS connections are pretty high bandwidth connectors. And so you couple this with what are called Sas Breakout Cables. The breakout cables basically have a single SAS connector, and they break out into 4 individual SATA data connections. So with a single LSI card, I gave myself essentially 8 SATA connections on a single card, and with 2 cards, I have 16 SATA connections. So I could, wire up 16 drives on this thing by itself. Now there are other SAS cards that offer like 4 SAS ports, right? So you can get like 16 on a single card, 32 on 2 cards, and some of the main boards offer you additional PCI Express slots, so you can continue to get more. I have seen. I was going to say, I don't think so. There are things called JBOD arrays. There's big boxes where you just kind of slot in drives vertically into these things, and they're pretty deep in terms of when they go into the rack. And those you can get to like 64 plus like drives. JBOD is JBOD, just a bunch of disks. Those are a little bit more advanced. That would cost a lot more, and it's really for like SAN or storage array networks. Like those are some more advanced storage engineering solutions. I would have loved to have been doing something like that, but there was no way I was going to get into that. That gets a little crazy. You actually have 2 different servers. You have a JBOD array, which is its own kind of box that handles like fiber connections, all sorts of crazy stuff. So you can have failover to other JBOD boxes, and then you've got SAN heads, which are individual servers that kind of talk with each other for failover purposes and replication and all sorts of crazy stuff. That was beyond the scope of what I was trying to do. So I just had this, main board. I had I think an Intel i3 CPU slotted in, 16 gigs of RAM, a 250 gigabyte SSD, which I was going to boot the Freenas operating system off of, 500 watt power supply to kind of, power everything. And this was all sitting inside of this 4U server rack. So I had the ability for 16 of these things, and so I had one card's breakout cable went into 4 of the slots on the one dock, and its other 4 went to the other dock, and then the other card did the same thing. So that way, each card had access to either backplane. And this kind of, just in case something died, I still, if the card died, I still had access to both backplanes. And that was the purpose of that, to kind of give some, not redundancy. Well, I mean, there's technically redundancy with it too, but just, fault tolerance in case, like I said, if one of those LSI cards were just burn out or die, the other LSI card still is able to deal with some of the rest of the disks. And so I also made sure I split the disks across all that so that, they were going across both cards. And I tested some of this, to make sure that if I were to lose a card, I think I just pulled the plug on one. I didn't pull the card out, but like pulled the SAS connector out to simulate a card failure. And everything worked out pretty well with that. So anyways, I have this configuration. So I bought 6 drives that were about 4 terabytes a piece, but because of formatting and parity with the RAID array, or with the RAID configuration, it came out to about 3.64 terabytes per drive. And then for the second array, I had 4 drives that were both 3 terabytes, so 2.73 each. And the reason I had this was I had bought 6 new drives that were 4 terabytes, and I had 4 2.73 terabyte drives left over from my previous file server that I was running. And so I put these into these arrays. Now, the way it's set up, like with the 6 drives, I have them in what's called a Zfs Pool, or ZFS Pool. And this is something that Freenas supports, and I believe even recommends. Yeah, it recommends that. ZFS is a pretty cool little thing. Storage people are probably going to kind of balk at that, and they probably have other ideas on what they think are much better. But I feel like it's certainly good enough, for like a personal file server to just go with a ZFS type thing. And so what I did was I had, of the 6 drives, 5 of them are actually in a pool configuration, and the 6th drive is set up as a hot spare. So the idea here is that if any one of the 5 were to die, like completely die, the hot spare would be brought on board instantly to kind of take over. And now that buys me time to pull the dead drive and replace it with a new one. Now with a 5-disc ZFS pool, I think I did ZFS 2. So there's different ZFS pool configurations. There's like ZFS 1, ZFS 2, ZFS 3. I think I did 2 on this this bigger one. So that means I can lose 2 of the 5 drives, and the whole volume itself is still intact because of how it does parity across the other drives. Right, so you can lose, in this case, I can lose a drive or lose a second drive, and it can technically rebuild that drive if you replace it with something. In this case, I have a hot spare that will take over one drive, and that gives me enough time, like, okay, I gotta buy and get another drive in here, so I can replace that one, and I can lose even a second one. I still, it's still buying me time. That would not be great. If I lost 3 drives, I would lose the entire volume. So I did the exact same thing with the second one, only this one's a ZFS 1, I think. Wasn't able to do 2 because I only had the 4 drives, so I made it to where I can only lose 1 drive, but I've got a hot spare in there as well. So if I lose 1 drive, hot spare comes online. If I lose another drive, then I'm still good, but I can't afford to lose a 3rd drive. That hot spare is kind of what's keeping everything alive until I can get a replacement. So that's the drive configuration. On the bigger volume, I have 9.32 terabytes. So if I had like 4 terabytes, you'd think I would have 20 or 19-ish terabytes to work with, but I'm sacrificing a lot of that capacity and volume to give me fault tolerance in the entire thing. So that's what I'm really kind of concerned about. Besides, 9.32 terabytes is a decent amount. And so, my family's been putting a ton of like family pictures onto this, and I'm comfortable with the fault tolerance. I can lose, 2 discs, even a 3rd, technically, with the hot spare kind of making up for that little bit of a difference, and I still keep all my family pictures. Now, this still isn't enough. So, we still keep things on the external drive as a kind of a backup. So things get pulled off the phone, they get pulled off the phone onto the external drive. And then everything's copied up onto the file server where it's, protected there. So these have 2 different mediums. I think when they talk about mediums, though, they're like, not everything on a single, like hard drives, right? You want like tape, maybe, or you want something else, like a DVD. That would be the second type of medium. I think it's okay though, just that it's in a couple different places. I feel pretty comfortable with it being on the server, especially with the RAID, with what essentially amounts to a RAID array, the Zfs pool, kind of protecting things. The other volume is about 4.92 terabytes total, and that's really just for the media server, right? So I've got a bunch of DVDs, and we found that we were like not really watching a lot of them. We kind of want to, but it's like, oh, we got to turn on the DVD player, and then we got to go fish this thing out of a chest or out of a drawer somewhere, and then we got to put the disc in. We got to kind of run. It's like, this is like not very convenient. Especially we've been spoiled with Netflix and that kind of thing, and so I use an MB server. I run that, and it is looking at this 4.92 terabyte volume, and that's where I basically took all the DVDs and I started like making like digital backups for myself. And no one else has access to our MB server. It's very much a local thing, so it's just for our family. But it makes it a lot easier because the MB interface looks like Netflix, and so we can just wrap very easily, just pick out a movie off of that. And we got a lot of movies on there, just our DVDs. I don't really like getting rid of DVDs unless we never watch this thing, right? So then we put them in a yard sale and I delete them off the server. That way I don't forget, and then we sell them. But it's super convenient to have them on there. I don't really do that with the Blu-rays. Blu-rays are far more protected. I just don't bother. We don't have a ton of Blu-rays, so we just kind of keep them in the cabinet. I'd like to get those on there, but it's just a little more involved. So anyways, going back to the whole 3-2-1 of backups. So 3 different places, 2 different mediums, 1 off-site. One of the cool things and one of my favorite things about this Freenas setup is that we have what's called cloud sync tasks is something that Freenas offers. And so what you do is you can get like an AWS account, or I think you can do an Azure account. They also interface with Backblaze. So I picked up a Backblaze account, paid account, created 2 buckets, one for my file share and one for my wife's file share. And so I have what amounts to offsite backup, right? So we put a bunch of stuff on there, and then like every single evening around like 2 a.m., I think, an rsync task runs that will just like recursively run through the folder structures of whatever, share that you told it to point to. And it will take everything that was added and it will synchronize it up to, in this case, Backblaze. And so this gives us our offsite backup. So at the end of the whole thing, we have this really cool setup where, putting stuff on the server is pretty fault tolerant. We can lose a disk or two and everything still just runs and I can replace it and all that kind of good stuff. But if the whole house were to get cratered for some reason and we lost everything here, I could still technically pull everything down from Backblaze. I think that it costs more. I think where they make their money, well, where they could make their money is when you pull stuff back down, right? Uploading stuff, they charge you to hold it, and I don't think they charge you for uploading it. I don't really know. I pay like a couple of bucks a month just for having this Backblaze account with like multiple terabytes of family pictures up on it, so I think it's okay. But it works out pretty well. We have that kind of backup, so if something bad were to happen, like I said, the house disappears or whatever, I could get everything back up, and I can just say like, hey, synchronize with my Backblaze account, and it just pulls all that stuff back down. Then we have all our pictures back down locally. So I've been pretty pleased with it so far. And Freenas also offers some other things too. When you with the file shares, you could put stuff on there and it will actually like look at the files themselves, not look at the data per se, but like look for ways of compressing things. It's called so it does compression, LZ4 compression. So like if you put like a text document up there, text tends to very easily be compressed because there's a lot of like repeating data, like just individual characters get repeated like in a document. Like how many A's are there, how many B's are there, how many C's are there, and it kind of compresses them all down. I'm not familiar with the actual compression algorithms that it implements. It says LZ4, right? Yeah, it says LZ4 compression. So it's not something like a Huffman compression. I think we maybe moved on towards a modified version of that. I'm not really sure, but it implements this compression. So like, whereas the files might be like, let's say they're like, 20 gigs in size of all these different files, the compression might be able to bring that down to like 18 or 17, depending on the type of data. Like JPEG data or image data tends to already be compressed fairly well, so it doesn't really get a lot out of that. It's mostly like text, I think. I very well could be wrong. There's also deduping stuff, which doesn't really make, that's not really a thing for us because we're not doing a lot of duplicate stuff. If you were in a more corporate network, there's probably a lot of people that are storing similar documents, similar whatever on there. And so in a bigger corporate network, we have a lot of people, and there's a very good chance that there's some duplicate files being put on there. The dedupe thing will actually look for that kind of stuff and, not store it twice. Which is interesting. I think there's some other stuff too, like if there's like patterns of bits that are similar, I think it might do something like that, but I'm not really sure. That goes beyond my pay grade. So anyways, I have this really cool file server. I think in total it was close to about $1,400, I think. The discs were really expensive. I mean, the case itself, I think, was like $100, and the cards were like $60 a piece, and like that really wasn't one of the expense. The expense was the discs. They were about $100 plus each, and getting 6 of them came to about $700 some odd dollars, and which is everything else. Like it all, by the end of it all, maybe it wasn't it wasn't like 1,400. I think it was definitely over 1,000 though when it was all said and done. But I'm very happy with it. It's lasted a couple of years. Freenas does a pretty good job of interfacing with the hard drives using SMART or SMART to kind of check on the disk diagnostics, make sure everything's healthy, that there's no like big issues. And it kind of, keeps me apprised of what's going on. It can email you if there's alerts and that kind of stuff. So I check it on a regular anyway. So just to make sure everything's going smoothly, they don't have a dead disk and I have to go and replace it. So I've been pretty happy with it. No complaints, been very pleased. It's done a really good job, plenty of space. I don't really see myself having to increase it. And I could, like if I needed to increase it, I would probably take the hot spare out and put something else in it, a bigger disk in its place, and then, deactivate a disk and tell it to use that spare, and then replace the disk I just deactivated, just kind of do a rinse and repeat until every disk in the pool, the Zfs pool, has been replaced. And then once that happens, you can go into the pool and then resize it to make it bigger, and then let it do its thing to kind of rebalance everything it's doing. So there's it's a fairly easy path forward in order to increase the size of the pool if you need it. But right now, I think these 4 terabyte drives in there is like I've got about 9.32 terabytes of total space. I'm not even close to using half of it right now, so I think I got a ways to go. The disks might die before I reach its full capacity. But when the disk die, I'll probably dump in something that's slightly bigger. Might as well. Depends on the cost, though. I mean, I guess I could buy more 4 terabyte drives, but those will be a little older, so I want something a little bit newer. Because some of this hardware tends to break down just by even sitting there. So I'd like to get something a little bit bigger as the disks die, but they haven't yet. But then again, I'm not really, this thing isn't like being used a lot. So like in a corporate setting, the disks are just like constantly moving. You have to worry about not just disk temperatures, but disk acoustics, right? So the spinning drives themselves produce these acoustic vibrations, and neighboring drives can cause the drives to the platters to actually vibrate irregularly, and it can cause some slowdown issues. It can cause some potential damage, and so there's a lot that goes into that. Storage engineering is actually, to me, it's really cool to read about, and I love talking to people about it, but it's not something I feel I have a knack for necessarily. I think I have just enough to do, stuff for personal reasons, but I really appreciate people who do get into that and are really good at it. It's always fun to talk to them and kind of pick their brain about different things, and I don't know, just really appreciate people like that. So that's my file server thing, or my file server setup that I have at my house. Been pretty pleased with it, like I said. So, let's just kind of want to talk to you all about that in case you were interested in building your own. It's not too bad. I did a little bit more of a professional setup for mine, just for what I intend to do, but you most likely could just get like you can get a regular desktop that can just sit somewhere. You can get like an IC dock that will do, you don't have to do 8, I mean, you can do like 4 or something like that, 4 drives in a 5.25 bay, or it takes up 2 or 3. So you can very easily kind of make your own, just, maybe you can't get a couple different arrays, but you can at least get one. Just even having like a set of like 3 or 4 disks that support this would be more than enough to protect your family pictures. And then setting up a cloud sync task to put that stuff into an AWS S3 bucket, or maybe a Backblaze bucket. It's up to you. I just think it's worth it for sure to kind of have that set up. Just to kind of keep your family your family pictures safe. I would really hate to hear someone lose all of their family pictures to an external hard drive that, just failed. So if you haven't done that, I know it's not cheap, but it's definitely worth it. If you can't afford that, though, I invite you to at least do burn stuff to DVD and keep it in a fireproof safe. And that's a little bit more work, but it's definitely a lot cheaper. Just buy an external hard drive. They're about $100. Then just buy a spindle of DVDs and just start burning stuff, right? And then you just start keeping them, maybe every year or every couple months, just like burn a bunch of stuff onto DVDs and just keep them in a safe. So that's all I've got. This will be posted on my Anchor FM channel, which goes out to a bunch of other podcast servicers, and then it'll also be posted on my YouTube channel, Ready Rhino 1. So if you want to ask any questions, then, leave a comment, like and subscribe. I'd love to hear from you, and definitely interact with you and answer some questions if you have any about setting up your own file server. So hope you all have a great day, and I hope you'll tune in next time. Bye.